Okay, so now we're going to find out the exact molarity of our EDTA, and this is what's called standardization. So we're going to use that calcium solution that we made. Now remember, when you did this, you weighed out the 0.3611 grams and put it in 250 milliliter volumetric. So when you calculate this, you can calculate the moles of calcium, and then you can go ahead and find the molarity of this solution in the 250 milliliters. Now, when we titrate, we're not going to titrate all 250 milliliters. What we're going to do is only take a 25 milliliter sample. So I'm first going to pour some into a beaker because it's easier to pipette from that. And so I pour some of this into my beaker. And now I'm going to use a volumetric 25 milliliter pipette. And so we're going to go ahead and use our pipette pumps, where we go ahead and use this and suck up the liquid. And once again, just like the volumetric flask, there's a mark on this. And you want to go ahead and pipette up to that mark and not go past it. And you can control a little bit with it. Just a little bit more. And there we have it. So now when you transfer it over here, you push on the lever and it releases it. And that gets you exactly 25 milliliters. It's much better than using a graduated cylinder. You have an exact amount in here. It takes a little bit of time for this to drain, but that's okay. We have patience. Now with these volumetric pipettes, they will leave a drop in the tip. It's designed that way, so don't blow it out. Okay, we'll put that over there so it doesn't roll away. Now we have our sample, and we're going to treat it just like we did our blank. We're going to add our 5 milliliters of our pH 10 buffer. We add our 8 drops of Kelmagite indicator. Okay. And then we're going to add our 15 drops of the magnesium chloride solution. And this, we might add a little bit more, but that's okay. Okay, so we've got that all set. Now we're going to titrate just like we did again. Notice it's that nice red color, and we're going to titrate until it goes to that blue. Okay. Now this should take more than it did for the blank. Okay. Typical titrations take between 35 to 45 milliliters. We're going to add this, and I'm starting at 0.00 milliliters of my initial EDTA volume, and we want to add and swirl at the same time. So I'll go ahead and add and swirl. Okay, now notice it's starting to turn a little bit blue, so I'm slowing down, and I'll add just a little bit more. And there we have kind of a purple, but when you look at the piece of paper, it does look blue. And so there you have it. There's the end of the titration. And when we read the burette, we see that it is at 43.90. So 43.90 is our final volume for that titration. So we did trials 2 and 3 for the standardization, and in trial number 2, our initial volume of EDTA was 0.001 milliliter, and the final volume was 43.95 milliliters. And in trial 3, we used 0.00 milliliters as our initial volume of EDTA, and our final volume was 44.02 milliliters. Now remember, for each trial, we used 25 milliliters of the calcium standard. So for the last part of this experiment, now we have standardized our EDTA, so we're going to figure out the actual calcium carbonate content of hard water. And to do this, what I did was I took a 50 milliliter volumetric pipette and used the same pipette pump and dispensed it into this flask. And now we need to add our 5 milliliters of buffer to that, along with our 8 drops of calmagide. And then finally, we're going to add our 15 drops of the magnesium chloride solution. Now, if you get too much magnesium chloride, it's not a big deal. Magnesium chloride's there just to make the endpoint a little bit sharper. It's not critical the exact amount. So in this titration, we're starting at 0.01 milliliters for our initial volume, and we're going to add. Now, the water samples don't tend to have a large amount of calcium in them, so don't go too fast on your first trial, because you may not use as much as you think. Starting to see a little bit of a color change, so I slow down. And that's probably purple, so let's add just a little bit more. And so this is the hard part of these titrations, because I don't know if that's actually purple or blue, so I'll add just a little bit. And that's probably about as blue as that's going to get. I know it looks a little purple, but with the volume change, it doesn't really change too much. So we'll go with that. And we've got that at 28.6. Now, I'm going to do that. I'm going to write that down. I'm going to put it as 28.60. And I'm going to go ahead and add a little bit more just to see if I do get a different color change, because I still think that's a little bit purple, but I don't want to add too much and then have it not change on me. You can see it's not really changing. So I would say that probably that original one was a nice, where it was going to change. So 28, we'll go with 28.6 milliliters for that final. So we completed the final 2 trials of the hard water sample, and in trial number 2, we still used a 50 milliliter sample of the hard water. Our initial burette reading was 1.02 milliliters of the EDTA, and the final burette reading was 29.32 milliliters. In trial number 3, we used 0.5 milliliters as an initial volume in our burette, and 30.01 milliliters as our final volume in the burette. And remember, the burette contains the EDTA. With all this information, you should be able to determine the water hardness in this sample.